Good afternoon and welcome to the National Museum of Computing. I'm Andrew Herbert, the Chairman of Trustees, and it's my pleasure to introduce you to this year's Tony Sale Award ceremony on behalf of the Computer Conservation Society. I should say it's a warm welcome. That's partly because I was showing off EDSAC at the back of the room, which is my project. It's in the happy state now that it runs programs but doesn't calculate the right answer, which demonstrates the modularity of the machine. The central processor is central processing. The arithmetic unit isn't quite, but we'll get the two talking to each other nicely, and hopefully we'll be in good shape. We have a saying in English of preaching to the choir. I think I have the unusual privilege today of preaching to two choirs, because this is a CCS, Computer Conservation Society event hosted by the National Museum of Computing, and I kind of belong to both, and many of the faces in the room are familiar. But let's take ourselves through. So my job is to do the introduction. I'll introduce you to the Computer Conservation Society, introduce you to the museum, say a little bit about Tony Sale and the award, and then I'll hand over to my good friend Martin Campbell-Kelly, who will talk about the judging and the submissions and announce the winner. And there's a lot of overlap between the Computer Conservation Society and TNMOC, especially in the founding days, and the common factor is Tony Sale. And so it's very appropriate that we should be here celebrating his award. So the Computer Conservation Society is a specialist group of the British Computer Society. I think I have to say the National Society for Information Technology or something. Someone will know the entire catchphrase these days. One used to just be able to say BCS and everyone knew what you meant. But there you go. And as a specialist group, that essentially provides us with the means to exercise our aims. The origins of the group were a joint venture between the British Computer Society, the Science Museum in London, the Science and Industry Museum in Manchester, and the National Museum of Computing as it was emerging. The aim of the society is to promote the conservation, restoration and reconstruction of historic computing systems, and indeed it grew out of a group of people who are working on doing precisely that in the Science Museum in the 80s. To develop awareness of the importance of historic computing systems. That's probably something I feel more and more in this museum. We have a lot of school parties who come round, and all these kids with their iPads and their iPhones have very little idea of how computing started, and they're amazed to see the early machines, about how big they were, how limited in what they can do. And certainly I think back to EDSAC, my project. If I could take a time machine back to 1947 and say, by the way, Morris will be carrying at least one of these around in our pockets, using it to take movies of each other and so forth, I suspect he would have been appalled because he thought the machine was there to support scientific calculation. An important role of the Computer Conservation Society, and it's something this museum has drawn on a great deal, is to develop expertise in the conservation, restoration and reconstruction of historic systems. That is a growing challenge. Those of us who remember how to build and repair and diagnose valve circuits, there's a diminishing band. Even those who worked in terms of transistor circuits are at least my age. And so retaining that expertise, writing it down, using it and so forth is a very important thing to do if we're going to continue to be able to do projects of the kind that the CCS has supported, that this museum does, and to keep those machines that have been preserved running. Obviously, we look to represent the interests of the Computer Conservation Society with other bodies, and so we have relationships not only with TNMOC, with the Bletchley Park Trust, with the museum in Manchester, and other groups. We look to promote the study of historic computing systems, their use and the history of the computer industry. Now, if I look around the room, I see several authors of publications, books and so forth on that subject. I think that is very important. These things get written down. We all have memories of our career, whether it's in industry or academia or whatever, but if those things aren't written down, they get forgotten. And as the years go by, memories get a bit blurred. In 1999, Cambridge had a conference celebrating the 50th anniversary of EDSAC, and there are a lot of recollections written down, which I thought would have been quite handy for us doing the EDSAC reconstruction. Sadly, a lot of people blurred in their minds EDSAC, the original machine, and EDSAC 2, its successor, because enough time had gone by then. So these things do need to be written down, and the talks and so forth that are given are very important. And then, obviously, to publish those things. So that's the Computer Conservation Society. National Museum Computing is a little younger in terms of its foundation. We are a company limited by a guarantee with charitable status, as are many museums, and there's a tremendous overlap in the aims and objectives. So our aim is to bring to life that history, to inspire our visitors, to help them learn about the history of the subject, both general and specialist publics, and also to support research, people who want to delve in deeper. And it's one of the pleasures of working in the museum is you never know when you're talking to a visitor whether it's going to be, as it were, a member of the general public who just wants to know something about computing, someone who works in the industry and is desperately keen to see whether you do indeed have the left-hand spindle of an ALWAC 3E. And if you make the mistake of finding it and showing it to them, they will tell you the ins and outs of every rivet on it. But that's quite fun, actually. There was an ALWAC 3E, it was an American computer, by the way. Whether it had a left-hand spindle and rivets, I don't actually know, I'm bluffing. But there's the pleasure of talking to the expert visitors, there's the pleasure of talking to the general public, and the real pleasure of talking to young people who are thinking about computing as a career and helping inspire them. Certainly computing provided me with a fun career, and even though I'm retired, I think I'm still pursuing that career actually, just doing it unpaid these days, but that's fine. So we support, acquire, conserve, restore and reconstruct historic computing machinery. You're in the perfect room to support that aim. Behind me is the world's oldest original still working computer, the Harwell Decatron machine, known as the Witch. And on the other side of the room is EDSAC, our latest reconstruction project. When I took that on, and I think it's in 2011, we thought we'd have it done in 4 years. Well, here we are, 12, 13 years later. We might actually finish it this year. I've been saying that for about the last 10 years too. But we get nearer and nearer. Obviously an emphasis on British computing heritage and the British contribution to innovation and development in computing. Again, a story that is not well known of how much we were in the lead in the early days. And indeed that continues if you look at the number of Brits who are involved in the major computer companies and their technology. For us, the key thing about this museum is to have as many of our exhibits as we can, interactive, working, so that you can actually see what they would like to use, and having put EDSAC on earlier, also feel how warm it was to use. I find my volunteers are much more keen to come and work on the machine in the winter. In the summer we have to have all the doors and windows open. And alongside our exhibits, our tours and so forth in the museum, we do a lot to provide a wider context through our education program, our Bytes festivals where kids can come and play with technology, our lectures, visitor activities, and so forth. And our aim very much is to inspire future generations of computer scientists, engineers, and inventors. So let me say a little bit about Tony Sale. I'm sad to say I only met Tony once. I was working for Microsoft running their research lab in Cambridge, and we had our American management come over, and I thought I'd better do something to entertain them so they go away happy with the lab. And I was aware that there was this guy doing something with a Colossus code-breaking machine that story was starting to emerge, and that you could book a tour. So I booked a tour for my guests and discovered you could also book a dinner in the mansion in the evening, and brought my American colleagues here. Tony did the tour. Tony gave the after-dinner talk, which in Tony's style was very scurrilous, but also very informative. They went away very impressed. They did not know the story of Bletchley Park. They did not know about the code-breaking machines. They enjoyed slightly eccentric Brits like Tony. Then I justified my lab as I'm just going to hire eccentric Brits, and that's what Microsoft needs. But Tony had very much a portmanteau career. He's an electronics engineer, a computer programmer, a computer hardware engineer, computing historian, and indeed a museologist. save you rushing for the dictionary or Google. That means someone who studies museums. He had views on how museums should operate and what they should do. He was a founding member of both the CCS and TNMOC, and his thinking about the museum and having objects displayed, reconstructing things that were missing from the record very much stemmed from Tony. He campaigned to save Bletchley Park, leading to the foundation of the Bletchley Park Trust, who are our landlords and operate some code-breaking museum just down the road. And he's led the Colossus computer reconstruction, which when I did my research, the dates of that were 1993 to 2008. So if it took that long to do Colossus, which is in terms of valves about half the size of EDSAC, I think I've got a bit of runway left. So to the Tony Sale Award. So the object of the award is, each time it is given, to recognise a singular achievement in the area of computer conservation and restoration by a person or group, and to give public recognition to that work worldwide. The emphasis of the award is very much on a practical project and can embrace hardware and or software. The criteria against which the submissions are judged is their originality, what is novel about the approach that's being followed, completeness, has the project achieved its original goals, and that can be a challenge, as Tony knew with Colossus. I'm saying nothing about EDSAC. Ingenuity, are new techniques or processes being introduced, and I think that is an important topic as these machines get older and we have less expertise available to look after them. The more we can do, for example, to automate fault finding, diagnosis, maintenance and so forth, I think those would all be things that come into scope. The impact of the work, what was its contribution towards the understanding of the history of computing, and outreach activities to disseminate the work to public and experts. So I'm going to stop at that point and hand over to Martin, who's going to talk about the judging panel, talk about the submissions, and announce the winner. Oh, I'm sorry, I missed one slide. I should also have thanked our donors, Ben Trethowan from Polynomial, Richard Conway from Elasticloud, and Peter Membray from The Engineer, who provided the financial support to host the event. And well done, Jackie, for securing their sponsorship. So, the award. Martin.
Hello. The Tony Sale Award began in 2012, and it was set up as a biennial event every 2 years. But it was interrupted by the pandemic. So the last time we made an award was in 2018. The award's always been international in scope, and this year was no exception. We had 5 entries, 1 from France, 2 from the United States, 1 from Ukraine, and 1 from the UK. In keeping with the international scope, I tried to assemble an international jury of judges. So let me name them and thank them. From Germany, David Link, who is an artist and a media theorist, was one judge. He was actually the first winner in 2012 of the Tony Sale Award for a stunning exhibition involving the Manchester Baby computer. And I'm delighted to say he's here today. Oh, there he is, yes. From the United States, we had Paul Ceruzzi, who is Curator Emeritus at the National Air and Space Museum in Washington, D.C., part of the Smithsonian Institution. He's going to be here next week. He's visiting family in Oxford, but he just couldn't get it to coincide to attend this event. Our third international judge had to withdraw midway through our deliberations. So I must say I'm very grateful to Professor Simon Lavington, who filled in the breach at very short notice. Simon will be known to you all as the author of many books on the history of British computing, and particularly on the Manchester computers. He's currently on vacation in Cyprus. I emailed him yesterday, and if his family allows, he's going to be tuning in by Zoom. Our fourth judge was Professor John Tucker, who's a former Pro-Vice-Chancellor of Swansea University and head of the Department of Computer Science. He was actually the instigator of the TNMOC Honorary Fellowship, and also the founding editor of the Springer series in the history of computing, which I think now has about 15 volumes. And our last of the five judges was Professor Jonathan Bowen, who's a past chair of the British Computer Society's specialist group on formal methods, and he's chairman of a museum consultancy called Museophile, which advises museums in the digital age. Well, today he's external examining in Dubai, so I'm afraid he can't be here either. One thing all the jurors said, and independently, was that they were truly impressed by the incredibly high standard of the five submissions. And it really was a very protracted and difficult process, picking one of those to be the winner. But that's the rules of the game. Three of the submissions were for virtual rather than physical reconstructions of computing, which I think is an interesting development, really, that Andrew alluded to. The world is changing. We had a web-based virtualization of Flossie, the British ICT 1301 computer. We had a simulation and a software reconstruction of Ukraine's first computer, the Kiev. And Yuri is here today.
Yeah,
hello, Yuri.
hello.
Thank you. And thirdly, we had the SimH project, which is a simulation system that enables you to simulate virtually any computer of a standard architecture. A fourth project was a software restoration of Medley Interlisp, which was Xerox PARC's version of Lisp, which was developed from the 1960s onwards. Well, however, as I say, there could be only one winner, and after much deliberation, the Tony Sale Award for 2024 has been awarded to France's Association MO5 for the hardware and software reconstruction of the Micral N, France's first microcomputer developed in 1972. Well, as you know, computer historians are very cautious about nominating the first of anything. But without doubt, the Micral N was one of the very earliest microcomputers. And there are perhaps three computers that could be disputed, but it was certainly one of the very earliest. So over to you. I think it's time we presented the award. Right, Jackie's going to please stand.
There is your certificate for the wall. You can hold both, but carefully. There we go. You just face that camera there.
So Okay, I'm standing here before you. I thank you very much for having me. It's a great honor to be here today, especially since I'm only the messenger. Yeah, I actually on the project I didn't do much. I'm only the trophy bearer. Well, if only for a few seconds. So in order to give credit to all the people who work on this project, I'm going to start my presentation with the people behind this project. So again, thank you very much to the CCS, to TNMOC, and also to Tony Sales Legacy. It's a great honor to be here today, especially in this mythical place. I'm overwhelmed. As I said, I'm only the messenger, so I've been having imposter syndrome for the better of the last week, and it just came to a high with all these, these presentations, and to be sandwiched between two of the oldest machines in the world, it's really an honor. So the Micral N project. Who are we? So who is MO5? So MO5 is a French non-profit organization, which has been founded in 2003, and so the goal of this organization is a bit like the two organizations, CCS and TNMOC. It's to preserve our digital hardware computing heritage. It's located in the suburbs of Paris, in France, and we have. This is a slide from the website. So a few figures on the association. We have more than 500 members, 10% of which are active, so which take part of all the events. We have quite a large collection. We have one of Europe's largest collections of computers, video game consoles, games, software, and documentation. And since the beginning, we have been doing a lot of exhibitions. So while it started slow in the last year, we had almost one exhibition every week or every 2 weeks. So this is a very important thing of MO5. We are trying to tell to the public how important computing history is. I mean, with all the kids who are born into IT, who don't know where it came from, I think it's very important to tell them and to show them all these beautiful machines. So, as I said, 50 active members, 8 of which are part of the preservation team, which I officially joined a few weeks ago. So I really like to give them credit, so I'm going to have a few slides about them. So we have Jean-François Delnero. He's really the hardware guy. He did all the reverse engineering. You might know him from HXC. HXC is a very well-known floppy disk emulator. You can buy or create your own hardware. It's available. The code is available, and he also for the task developed Pauline, which I'm going to talk about later. So his HXC floppy emulator is used in many different fields, like in this Boeing 737 simulator, and also for musicians' instruments. Sylvain Glaise, he is the brain behind the emulator we built for the project. So he is a software developer, and he helped Jean-François with the reverse engineering too. Then we have Hervé Le Boulet. So he's a bit of a computing history expert in our group. He did all the interviews with former employees of R2E, which is the company who made the Micral N. So he drove around France to make the interviews, to lead the interviews, and to collect different items from the people who worked on the machine. We have Johan Lebar. He's the software archivist, so he's in charge of of documenting, of keeping all the documentation of the machine and the software that we dumped from the read-only memories. We have Philippe Dubois, so that's our president. He's the boss. He's the founder of the organization, and he also does a lot of outreach. So all the live feeds, we have a live feed on Saturday to present the project and to talk about the prize. He did also finance the project. And then, last/least, myself, yours truly. I work at a computing center in Lyon, where we have a large data center run by it's called CCI2P3, and we collect and process data mainly from the Large Hadron Collider in Geneva. And so my job was, apart from bearing the trophy, was to do a few article translations online. That's it. So thank you to all these people who did all the work. So just a word before talking about the project itself. Are there others in France? Are there other organizations? Yes, there are a lot. And this is a real problem. I've heard from the talks, it's also a problem in Britain, that the government doesn't really care much about computing history. And we have the same in France. So we have many institutions which have museums or have a collection or have something to do with it, like CNAM, like INRIA, like CNRS, which I work for, like BNF. So all the names you probably don't know, but these are large organizations in France who have something to say, who have a collection. And then you have all these non-profit organizations like Silicium, Aconit, WDA, GPS, LLF. They all have, some of them have a collection, some of them have knowledge, some of them have members who know about computing history. And then we have thousands, if not tens of thousands of private collectors who have all their stuff. And all these people, us including, are waiting for something to happen where to put all this important stuff. We probably have doubles, triples, we have many things we could just, by combining them, we could get rid of half of them because they're already there in the collection. But we need to put this together and have a common ground to preserve computing history. So just the last word on the name of our organization. It's called MO5. So MO5 is probably France's most well-known computer in France. Who knows about the MO5? Okay, you see, only known in France. So it's our very own Speccy. Okay, it's like the Spectrum in the UK or the Commodore in the US. Why was it famous? Because it benefited from a government subsidies. In 1985, there was a plan from the government to get many computers in all the classrooms. So it's called, I think, Computing for All, Plan Informatique pour tous. And Thomson, the company behind the MO5, benefited, of course, from this plan. So many kids who were born in the 70s, they learned to program on this machine. So the Micral N, the real star of this project. As you can see from this slide, it's French. We have our favorite pet on the slide and our flag. So it's, as we could agree with the judges, we can call it one of the world's first commercially available microcomputers. So of course, microcomputer, from the definition, is a computer with a microprocessor. So it was released in 1973. At its heart is an Intel 8008 with a blazing speed of 0.5 megahertz. And it was very cheap at the time. It was 5 times less than a PDB-8. And I've seen a PDB-8 just in the room there. It's also more than 5 times smaller. So it was built by the company called R2E. It was a commission by INRA. INRA is the National Agronomy Research Facility. So they wanted a computer, and R2E built it. And then it was sold to a few companies. We know about the French motorway company. They had some of them, you know, for the tolls, where you counted the cars and everything. At a bank, Crédit Agricole, and Ron Poulenc, which is a chemistry company. So these are the known customers, but there probably weren't more than a few hundred produced. So this is a picture of the innards of our own Micral N. It's got serial number 194. It's got 16 circuit boards plugged into the backplane. So it's one of these computers where you have one backplane exposing the computer's bus, and all the electronic boards are plugged into it. So we had 16 of these, 16 circuit boards. Some of them, so all of them had one connection to the pluribus, so that's the backplane. And some of them on the other side also had interconnects with other boards or external hardware. So we analyzed all these circuit boards and did all that was necessary to have a working machine. So just a bit about how it started, how the project started. So it started in 2006. Our president was really, he really was very motivated to get one of these machines because we knew they existed. We knew some people owned them, but we didn't have one at hand to study it. There were so few informations about how it worked, what it did, what programs were run on them. Of the few hundreds, not many were left. And so he learned that there was one at Musée des Confluences, which is a large general purpose museum in Lyon. So he started to talk with these people and he wanted to study their machine. He was thinking, okay, it's a museum, right? So I can borrow the machine and study it. And, you know, it's a win-win situation. Well, it wasn't. 10 years later, there was an auction at Château d'Artigny. And there was a Micral N, very nice Micral N. Unfortunately, the co-founder of Microsoft had a bigger wallet than our organization, so it went away for 50,000. And it's now in his private, well, he's not among us anymore, but it's in his private museum. Fortunately, 5 years later, another piece popped up. So it popped up, and the seller, he told us, okay, I have one. I'm not giving it away for free, but I'm only selling it to you guys. So that was a big win. We had a pledge. We knew he was going to sell it to us, and we only had to find the money. So Philippe, he started a crowdfunding campaign, a very well, organized campaign, and to raise the money. So where are we now? Well, just to make, this could be the last slide. It's great, the crowdfunding goal is achieved. It was funded last year. The restoration is finished, is completed. And we published 13 online articles on the process of the restoration, documentation process, etc. And we even started to film a video documentary. So these were the goals of the crowdfunding campaign. We not only promised the people who gave money that we would restore and study the machine, but we would also give back to them by making documentation available and filming a series of video documentaries. If I want to go a little bit into the detail of the timeline, it's probably a bit small to see, but I'm just going to tell you about a few of the milestones. So as you can see, most of the work was done in 2021. That's why there's so many masks on the pictures. So for some people, 2021 was very productive. Many people stayed at home and they could work on many things they would like to, because their boss wasn't looking what they're doing, and so they could work on their own projects. Like Martin, I'm sure your 2021 was very productive. So end of February, we already had an emulator, an 808 emulator, a functioning one. In April, we built a device to dump the ROMs of the machine. We received in April many more circuit diagrams. We received new RAM chips to replace the faulty ones in June. And as we went, we always published the results online as we went. And this was very important because some of the people who worked at R2E, at the company who made the Micral, they reached out to us thanks to that. They reached out and said, hey, but I have documentation, I have one. And so we discovered people who knew about the R2E, who didn't speak up before we did the communications, we did the outreach. So that was really important. So in April, we got many documentation items which were very helpful to reverse engineer the missing parts. In June, we interviewed this person who reached out and who gave us many more information on the Micral. In June, we had the first power up, so we could actually start the machine, power it up safely. In July, the first boot. And in December, we had a suitcase. So I wasn't allowed to bring it along, I'm sorry. As a donation to the museum, no, I think Philippe would not agree. In 2021, things developed quite quickly. We did all the repairs which were needed, the cabling, the missing cables, the power supply, and by March we had games running on the computer. So that's an achievement, to have games ready. We had a port of Shooting Stars running on the hardware. So what were the problems that we faced during the... I'm sorry, I always say we, but it was them actually, right? I think you got that. So we had no power supply, we had no cables, we had no power cables, we had no board interconnects, we had no external hardware. We knew there was some, because from what we dumped from the ROM, we knew that there was something missing. We had no software. That was one of the big problems. Nobody had software for the Micral N, except what was on the ROMs. But we didn't have any hardware to dump the ROMs. And the documentation was scarce at the beginning. And as I said, in April, we had some more. But that came along. So what did we do? We, very early on, as it was 2021, and everybody was working from home, it was important to have high definition scans of all the boards, of all the circuit boards, so people could work on them from home. And also this had the benefit of not manipulating too much this old hardware. And also something which was decided very early on was to analyze the hardware and build the emulator at the same time, because both are really go hand in hand to do reverse engineering. This is an example of the CPU board, with which we have annotated with all the functions of the different chips. You can see the 888 on the top. It's got the yellow heatsink or heat, and you can see the circuit diagram which was sent to us. Some of them had to be redrawn. The ROM dumps. So how did we dump the ROMs? So these were 1702As, which were not supported by modern hardware or anything which is readily available. So Jean-François Del Nero developed this board you can see on the bottom left, which was used to dump the ROMs. And he later integrated also chip testing capabilities into it. So we could actually test the old 1K RAM chips on the board. So all of this is publicly available. You can get the code and the circuit diagrams on GitHub. So after dumping the ROMs, we were ready to run some native software of the machine, but we had to replace a few RAM chips. So fortunately, these are still available on some sites, which I'm not going to mention, on some second-hand websites and other countries to the east. I think only 1 or 2 were faulty, so these were very easily replaced. And if I remember correctly, all the RAMs were socketed, so that was very nice. We didn't have to destroy the original solder. The emulator, so written by Sylvain, very early it was available. It's a cycle perfect emulator, and it has also a few useful tools integrated, like bus conflict detection. It has a built-in logic analyzer or logic display. You can see the traces of all the pins. Many circuit boards, so additional circuit boards, have been implemented too. And on the bottom you can see the command line interface version of the emulator, where you can run the code which sends data to the serial interface. And on the top right you can see the front panel simulation, where you can flip the switches and look at the LEDs. So there's also a GUI, and there's even an online version you can run in your browser, which is not too ready yet, so Sylvain didn't want me to give you the link yet. But you'll soon be able to play with one of the world's first microcomputers. So the development for the details, if you're interested, was done in C++ with this GUI library. I learned the existence last week. So the source code is also freely available on GitHub. Here are the links. Sylvain even wrote a custom assembler to implement all the special cases of the Micral N. So we had RAM chips replaced, we had the power cables manufactured, the power supply. We had tested all the circuit boards. They were running safely. There are no shorts in the connections. We're ready to boot the Micral N. So what happens? As we had the emulator, we could very easily see what was happening inside the memory. And what happens is that in the ROMs, in the boot ROM, which was installed in the machine, 14 bytes were read to memory. Then a reset happens. Then access to the ROM is blocked, and then something takes control. Something we found out was the floppy controller. Now what? Okay, great. We have a very old machine which boots and does something. So this floppy disk controller we reverse engineered is the one taking control of the machine just after boot, on the second boot. It's all cabled logic, and we were able to reverse engineer the disk format used by this computer. So it's 256 kilobytes, one side, 64 tracks, and some custom hard sector frequency modulation formats. So from the documentation we found online after some research, it looks like a Memorex 651, 8-inch non-standard mechanism. Great. Of course, these are very difficult to find. So for the ones interested, here's the floppy disk format. I'm going to pass this slide very quickly because I don't really understand it. So, machine starts, reads from ROM, and then reads from floppy. So we need to put something on that floppy, right? But we have no software. So that's not a problem. We can write it. We can write software. It's an 808. Sylvain wrote an assembler for it. So what do we run? Of course, we run blinking lights. Okay, we run the lights on the front panel and see if it works. We also had other possibilities on this old Skelby machine, where you can see the picture on the top bottom left, which is a very similar machine. Somebody posted the code, the assembly code of a game in Byte magazine, 1976. So cool, let's port that for the machine. And somebody even wrote a basic for the machine, Skelbal. So we could port this code for our machine, which is very similar, and run it, test it on the emulator, and then on the actual hardware. So we have software, cool, but we have no floppy. How do we put it onto the machine? We have a floppy disk controller. We know how floppy disks looked like, but we have no drive. So what do? Well, we grabbed this beautiful little device called Pauline, which was developed, maybe we had a debate, I think it's maybe between 5 and 10 years old, so it's pretty young. This device has been commissioned by a collaboration of the Game Preservation Society, La Ludothèque Française, and MO5. It's a device that was designed to dump any floppy, really any floppy. You could, on one of the connectors, you see these connectors on the top. You could either connect one or two floppy drives to it, and then on a standalone basis, you can dump these floppies on its SD card. So it's open hardware built on top of this amazing device called the DE10 Nano. It's an Intel development FPGA board, so it's a programmable chip. You can program it, and it was very nice because it's a pretty powerful FPGA, and it was cheap. It was very cheap. I think you could get one for less than $100. That was before COVID. Now it's more than 200 or 300. So, but yeah, so the Pauline is very well suited to dump floppies, and there's a second feature, which is one which was the feature we needed for this project, is the emulation part. So it can emulate a floppy, like HXC, the floppy emulator from Jean-François. It can also emulate a floppy disk. So if you use the other connector and you connect it to a computer, it can pretend to be a floppy disk drive. So that was great. We could use that device. It was developed by our in-house member, so he knows it very well. He modified the code a bit to adapt to the hardware of the Micral N, and we were good to go. We have a world's first, the world's first virtual floppy disk for the Micral N. So this is a screenshot of the HXC software, where you can see the tracks, the different tracks on the floppy disk. And on the right-hand side, you can see Pauline connected to the floppy controller. So thanks to this, we could generate a virtual floppy with our software and run it on the Micral. So blinking lights. That was the first day that we managed to run our own software on the front panel. So for the ones not familiar with these, you can simply visualize what's in the memory of the machine using the lights, and change what's in the memory using the switches. So you simply display something, you put something into your memory, and that shows up on the display. There's even I don't remember the name of the other. There's a game using the lights. You have to flip the switch just when the light comes. That's right. Sorry. Kill the bits, right? So that might be the next project for this kind of program. The next step was to write something on the serial connector. So there's a serial circuit board, which we were able to connect to a terminal. So here it's connected on some Linux machine, I guess, just to have the terminal, and the code would display this banner of our association. And we also run BASIC. So as I told you, BASIC was ported from the SCALB, and we were able to run it on the actual hardware. And games. Shooting Stars from 1976 runs on the Micral N. Not really sure about if that was intended, the machine's intended use case, but yeah, it works. So what next? What shall we do next? As I told you, the emulator needs some work, but it's to be more user-friendly. And as you know, it needs to be user-friendly so that people really can use it. And we want to finish the documentaries on video. We want to make more interviews. And as I said, reaching out publicly on Twitch, on the social networks, helped us because people who worked at R2E, they came back to us and they told us about their collection, about their knowledge on the machine. And these are some pictures of Jackie Dubois. So he's a former R2E employee, and he has a large collection of Micral hardware. So these are some of these machines he has, and he's more than happy to help us try to analyze and document them and repair them and anything. So there's the G model, the S model, the M model, and there's portable ones, loggable ones, many different computers that you are even less known than the MO5 abroad. Even in France, nobody knows about these. So, thanks again. Thanks again to CCS, to TNMOC, Tony Sane family, to Jackie Dubois, and also thanks to Pierre-Éric Mounier-Kuhn, who I believe already made some presentations to the one presentation to the CCS. He's the one who told us about the Tony Sale Award. So thank you. I think I didn't suspect we were going to win, but and of course thank you also to the people who paid for the machine. Viveris also, it's a French company who gave us access to their lab so we could reverse engineer the machine. And I'm open to questions.
Thank you.
Yes.
Nice wait for the microphone, please. Thank you.
Do you know how many working machines there are in France? I mean, how many are actually running?
So just for the record, we didn't rehearse that, but yeah, I wrote down that question. So how many there are? Probably 5 or 6. Yeah. So as you could hear, one is in the States somewhere, and one is at the museum in Lyon. One is in our headquarters, and Jackie Dubois, he's got parts and pieces of another one. You could probably build another one with him. And I think there's a 5th one we know of. So maybe more people will reach out. I don't know. Yeah. So maybe 10%. No, 1% surviving.
Are you looking for any of the application software for it? I mean, are we going to be able to pay our French road tolls to a Micral again or not?
Yeah, I'm not sure it will ever have a practical usage anymore, but if you have any software lying around on floppy disk for Mikhail, please reach out. But no, I don't think it was used in politics. It was only used in motorways and companies. That's maybe why the politics are not interested by old computers. I don't know.
You mentioned BASIC and you mentioned the assembler.
Mm.
Are there any other languages available on this machine, or were there, to be more accurate?
I'm afraid I'm not able to answer that question. I don't know. I really don't know. And BASIC was not one of them, anyway. So I'm guessing most of it was written in assembler.
You mentioned the memory chip P2102. What capacity was that, and is it static or dynamic?
It's static memory, and I think it was 1 kilobit.
1 kilobit?
Yeah.
Okay. I think I've got some similar ones at home. Unused, mint.
Unused. Working, we can test them for you.
We'll swap notes.
Thank you.
On one of the earlier slides, you said that the floppy disk emulator
Yeah.
was, I think, so copy protection capable. I'm just
Yeah.
wondering what that meant.
Yeah. So if you use the onboard floppy controller of the machines of the days, they were just written to read the data as it was supposed to be to read the data as it was supposed to be written. And some of the great minds at the companies who made the games, who published the games, they didn't want people to copy the games using what they had, and what they had was the floppy controller. So you couldn't, for instance, copy what was between the tracks or something. There was, they were putting bad data on purpose, and data like noise. You couldn't write noise with a controller, but with Pauline you can get everything as it was written. So that's why people at the GPS they are preserving all the Japanese games, and they want really the full Monty. They don't just want the data of the code, they also want what's around it. I mean, it's interesting to know how these mechanisms worked.
Yes.
Yeah.
Thank you.
Mm.
Hiya, you mentioned that the micro is equivalent to like the Spectrum, but did it ever see any particular popularity outside of France, or was it fairly sort of region-based?
So that was the MO5, which was similar to the Micral. And I don't think it was, I'm sure they tried to sell it abroad, but as usual, didn't work out. Yeah. It's like the Minitel, you know the Minitel? Yeah. You have at least one here. So we tried to sell it abroad, yeah. We tried. Yeah. Didn't work out. Over there.
Can't see the looking.
Got a second observation. You mentioned there Minitel, and my sort of impression from people I knew in France was that Minitel was much more prevalent than any form of personal computer, which seemed to take the market in the UK. I mean, where does this fit into the personal computer market? It seems that it only had, a few large customers.
So the Micral?
Yeah.
Yeah, Micral was very early, so nobody knew about computers back then. But the Minitel was huge. I mean, 20 or 30 million were in homes because it was free. We gave them to the people.
That's a very good point.
Yeah.
If it's free.
It was free. It was not 7,000 euros, but 0. So that's why it worked. But when you want to sell it to abroad, you cannot tell the governments it's free, because then you have a problem. But it's amazing. The Minitel is amazing because it's not only the machine itself. It's just it's just a terminal with a modem, but the services were there. I mean, you could do everything. It's like the web. It's the web before the web, 10 years earlier.
Yes, we had some similar things
You had video text or
in the UK based on using the spare capacity in television
yeah,
bandwidth.
yeah.
And a friend of mine actually ran a company using a system based on teletext. So you could actually issue bills of lading. You could actually issue shipping documents and lines of credit and so on
And
through
secret code.
through the system. So it was, you know, we had something similar in this country, but it was very limited in use.
Any more questions?
Maybe on Zoom someone has a question.